So good morning students. In today's video we are going to cover many important topics. Okay, so let's start. Development of the concept of isostasy. Determination of latitudes. The idea of isostasy came from studying how big mountains affect the gravity. So this whole concept of isostasy come into picture when these people, these like Pierre Boger and some sorry, Sir George Everest's British engineers, what they have found that the mountain they hang this plumb bob, okay, and the mountains attract though that plump bob, okay, but it didn't attract as much as expected from these mountains because they are very big. Okay, they should like pull away the whole plumb bob, but that doesn't happen. The plumb bob only like deflect only this much. So they wanted to know why does this happen, and that's where the concept of isostasy came into picture. Isostasy is Earth's balance. So nature keeps everything in balance. Earth also maintains a balance. So we all know that the nature and the earth maintains a balance. Okay, if the nature didn't do its work, we will be vanished in a second, in a millisecond. So the everything is working in a very balanced way. Rocks are eroded from mountains and deposited in valleys, keeping mass balanced. So the rocks are eroded from the mountain surface and they deposited in the valleys. So they maintain this balance on the crust. Okay. Mountain building and erosion happens continuously to maintain the earth's balance. The Earth's crust floats on the mantle like icebergs float on water. So we all know that the crust floats on the mantle, the asthenosphere, which is a little bit softer and fluid-like. Thick land masses sink deeper into the mantle. Thin crust floats higher. So we have already covered these things many times. Under continents, the crust is thicker. Under oceans, it is thinner. So we know that under the continents the crust is thicker, and under the oceans the crust is thinner than the means continents. Gravitational deflection and isostasy. Isostasy is not a force, it is a natural adjustment of the Earth's crust. So, here the point to know is that isostasy is not a force. Okay, it's not a force like the weight or the normal force. It is a natural adjustment of the Earth's crust. The crust has different thicknesses which helps maintain gravitational balance. The hydrological cycle, that is the water cycle, moves material around affecting this balance. Convection currents inside Earth's push and pull the crust. So what does this convection current mean? That means the hotter material uh, rises and the cooler goes down. So this happens continuously inside the earth. We will definitely gonna cover this convection current, I think, in upcoming chapters, so don't worry about that. But for now, it is simply the movement of this hotter material and the colder material inside the earth's surface, and this happens continuously, and it makes the convection current. Sediments collect in large depressions, geosynclines, and sink deeper. So what happens is these sediments collect in these large depressions, which is called the geosynclines. Okay, and it sinks deeper. Magma rises through volcanic activity and forms large rock bodies, batholiths. So magma rises through the volcanic activity. Okay, so magma, what happens is, now this volcanic activity happened, magma flows out, again the magma goes into the ground, and again of like through rock cycle, something like that. It comes up again, like things goes on and on and on. Okay, as we have covered in the rock cycle. And this magma, when it cools down inside the earth's surface, it creates big rocks. Okay, it's create big rocks, and that rocks is called the batholiths. That rocks, it's called the batholiths. When magma cools, crust uplifts, creating mountains which again erode. So this magma cools down and the crust uplifts, creating the mountains again. Okay, and which again erode. Okay, all these slow processes help maintain earth's long term balance. So because of these processes, like formation of the volcanoes, mountains, and then erosion, all these helps us to balance the crust. Okay, depth of isostatic balance. So let's see this topic, it's very easy. There is a level inside Earth where total weight is equal everywhere. This level is called the depth of isostastic balance. So inside the Earth's surface, there comes a level, okay, where the total weight is equal everywhere. Like no matter how the crust block is heavy or things like that, it is the area, it is the level where total weight is equal. Above this level, crust can move up or down to maintain balance. So above this level, that means let me draw a picture. This is the crust, and suppose this is the depth of isostatic balance. This is the crust. So above this depth of isostatic balance, the crust can move up and down. Like this means this crust will be like this, somewhere like this, somewhere like this. Okay, so this happens above this level, but at this level the weight is equal everywhere. Isostatic movement. Isostasy explains vertical movement of the land. So it helps us to understand the vertical movement. It does not explain sideways movements like the folding. Okay, like folding happens, or the plate movement. These are like horizontal movements. But isostasy help us to understand the vertical movements. Greenland is an example where land sinks because of the heavy ice cap. So, Greenland is an example where the land sinks. Here, the land sinks, okay, because of the heavy ice cap. Okay, heavy ice cap above the surface, because of that crust sinks, and Greenland is a good example of this. Ice melt. If Greenland's ice melted, water would flow to the oceans and increase sea level. So we know that global warming doing this. Global warming, global warming. I don't know. So global warming is doing this. Because of global warming, the total Earth's temperature is rising, and that leads to the melting down of the glaciers. And here's an example: in the Greenland, it is happening. Because of that, the water will flow to the oceans and increase the sea level. Land would slowly rise once the heavy ice weight is removed, and so of course the isostastic rebound happen when the weight is removed from the land. So what happens when the weight is removed? The crust came back to its position, normal position. After some time, the land would reach a new isostatic balance. So after some time, of course, the land would reach a new isostatic balance. So today's homework is to make an image in your mind explaining this concept. So what you have to do is to make a flowchart in your mind connecting all these concepts together. Okay, this way what you will do is you will make imagination in your mind. Okay, imagine your imagination will improve, and you will able to learn it little bit longer, of course. So yeah, just draw a picture in your mind, create flow charts connecting all these concepts with the previous ones, connecting the whole chapter, if if you learn this way, like connecting all the things, you will be able to retain things much longer. Okay, so that's it for this video. Thanks for watching.